Good day to everyone. Today we are going to see about Coulomb's law, which is based on this introduction about electrostatic force. In electrostatic force is what do you mean by electrostatic force? The electrostatic force is deals about that it's force between two different charges. The main objective is the Coulomb's law describes the electric force between charged particles. Oh, so this is essential. Yes, it is one of the important to understanding the electromagnetism and the behavior of charges. So I am Dr. Shubha Veka, Assistant Professor in Physics, Nadar Mahajana Sangam, S. Velechami Nadar College, Madurai. So what about charges? The charges has two different types. One is positive and another one is negative. The interaction between charges are like charges repel, opposite charges attract. Simple. The quantization, what about quantization means the charges comes in multiples of elementary charges, that is 1.10602 into 10 power minus 19 coulomb. What is C? Here C is the charge, that is a unit of charge is coulomb. So this is Coulomb's law is the force is directly proportional to product of 2 point charges, that is q1 and q2, and the inversely proportional to the distance between them, that is the r square. It's a square of the distance, that is r square. Here the force is the electrostatic force, the force in the newtons. Already we know the unit of force is Newton. Then what about Coulomb's law, that is electrostatic force? There is the also Newton, the same unit. So what about the Coulomb's constant? We know every proportionality constant, every proportionality cancelled by one constant. Here we introduce the constant K. The value of constant K is 8.9875 into 10 power 9 Newton meter square divided by C square. So the charge of the magnitudes q1 and q2, the distance between them, it's the meters. So what about the specific value of k is the k is equal to calculated by using this formula 1 by 4 by epsilon naught. So we can the epsilon naught is 8.854 into 10 power minus 12 c square by Newton meter square. What is the role of the k? It determines the strength of the electrostatic force in vacuum. So in this figure we can see the pictorial representation of Coulomb's law. q1, q2, q3 are the three different charges. F equal to k q1 by q2 divided by r square. So the r is the distance between the point charges, where r is inversely proportional to F. Whether r will be increased, the electrostatic force will be increased. No, the electrostatic force will be decreased because they are inversely proportional to each other. For the charges are 1 proton equal to 1.6 into 10 power minus 9 coulomb, the same electron equal to minus 1.6 into 10 power minus 19 C. So the charges will be different, the signs will be different, but the quantization will be same. So the force F equal to K q1 q2 divided by r square. This is the Coulomb's law. So for the example problem, here we can see the three different point charges. 2 are positive and 1 is negative. So what is the sum of the electrostatic forces? So we can calculate the force on Q2 because the Q2s are different. The net force is the vector addition of individual electrostatic forces. Let's given our given problem, the given values are charges 2 mu c and minus 3 mu c. The distance between them is 2 millimeter. So now we calculate the electrostatic force by using the Coulomb's law. We know the formula. Now we substitute these values in F equal to K q1 q2 divided by r square. Now we can find out the value 13.48 Newton. That is, the force between the 2 point charges is attractive because the charges are one positive and one negative. So the force, what is the here N? N is the Newton, the force of the Newton. So these are the applications of Coulomb's law. You are thinking about Coulomb's law, that is used to only find out the electrostatic force between them. No, the real life applications is lots of there. The electrostatic precipitators, that is it can be used to remove the pollutants with the efficiency 99% by using this Coulomb's law only. Nowadays we take a laser printouts that toner sticks electrostatically for high resolution printout, then only we get the printout from printer. So simple application also based on this Coulomb's law only, and the particle oscillators also used by this Coulomb's law. So now I hope you have some basic ideas about Coulomb's law, the fundamental things, and I hope you will understand the what is the force between the two charges, how to calculate the electrostatic force between them by applying the Coulomb's law. Next class I hope this Coulomb's law will be help to more information, and also it is one of the foundation for this future classes about electric field and potential like this. Hope you soon. Thank you.